So there's a few ways that you could do this question, but one way, the way I would do it is I would add this fraction to the other side.
Ew.
So that I could then cross multiply.
Sure.
Otherwise, you could find a common denominator. So if I cross multiply, I get a squared minus b squared equals c squared.
That's so much easier.
Now since we're solving for c, I would then square root both sides.
Break down my words.
Oh yeah, go for it.
Yeah.
Thanks.
When you square root this, make sure you put the plus or minus in front. And then you may or may not be able to simplify what's inside. Now, when you simplify a square root to something, you're saying that that something times itself is this. So it's tempting to say that the square root of a squared minus b squared is a minus b, because they both have the squared and it makes sense, but it doesn't make sense, because if you say that the square root of a squared minus b squared is a minus b, then what you're saying is a minus b times a minus b is a squared minus b squared.
Oh yeah, because you're.
But if you FOIL this out,
It's wrong.
Ooh, it actually happens to be that annoying.
you get something completely different. Okay, this is not this.
Okay.
And so you can't simplify them in that way. Now, if you're talking the square root of a squared times b squared, this is, since they're being multiplied, there's a property that says you can separate this. Okay, that was one of the properties. There is no property that says that you can do this.
Oh, because they're being subtracted, so.
That's not a thing.
Is that okay?
No property says that. One property says this. So in this situation, this would simplify to a b, because you can square root a squared and you can square root b squared. But if there's a plus or a minus sign in here, you can't do it. And it's the same reason, like it's all kind of falls under the same category as why you can't do this. Okay? You can't do that either. It's not allowed. This is a no.
Wait, if it was a,
Here.
if it was a squared, if it was a squared plus b squared, wouldn't it be a plus b?
That doesn't factor at all, because that's a sum of squares, so that wouldn't factor at
You're
all.
right.
Yeah.
A plus B is supposed to be.
A squared plus b squared, if you wanted to factor that, you would need imaginary numbers. Because you would need a difference of squares. Okay, the square root of this is bi. And the square root,
I
so you'd
forgot how
have
to
one
do that.
positive, one negative. That would be how you would attempt to factor that. You need imaginary numbers,
Ew.
which you wouldn't do.
A plus by.
Substitution method is going to be the method we want to use. It's going to be very difficult to eliminate for some of them, and so we don't want to necessarily do that. We're going to use substitution. So in order to substitute, you have to isolate one variable and then substitute its stuff into the other equation.
Let's isolate the y because that one just looks easier.
Oh no, that's not a good idea. Look, it's already isolated.
Yeah, come on.
Oh, I was looking at it backwards. I was looking at it
Plug it in.
backwards.
You
I was
could,
gonna do that
so you
too.
could isolate the y if you want, but this one is already isolated. It says x equals y plus 1.
Oh man, not my best morning.
So what we're going to do
Plug it in.
is plug y plus 1 in for this x. That's the easiest method.
One fifth.
So we'll get y plus 1.
Minus 2. Or 2, negative 2.
Black mark again.
Oh no.
You drafted.
Minus 2.
Minus 2 equals 6 over y.
Do you distribute the minus 2?
It's not being multiplied, you're just subtracting.
Oh, so negative 1. I mean, yeah. Why does it look like that?
You're going to be left with some sort of rational equation, most likely, because that's, again, the whole point of what we're doing here. And so, I know that it's weird that it's a y, but just get past it.
Wait, why did it turn into y minus 1?
Because you
Because
multiply.
1 minus 2 is negative 1.
I don't like that you put
Oh,
that.
you don't
put the
distribute?
parentheses. I don't like that.
Every time you substitute something, you should put parentheses.
But that looks very.
Yeah, it messed
It
my.
just confuses.
I
me.
know,
brain
but
up
it
and a
is
half.
mathematically, notationally accurate.
It makes it look like you're multiplying, like you're distributing the
Yeah,
negative 2.
it really
Shouldn't.
It compiled me.
But
Get past it.
do I have to, or are you gonna like kill me if I don't?
It's notationally accurate, and in certain circumstances will yield the wrong answer if you don't put parentheses around it.
I'm gonna distribute the 2 next
In
time.
order to
because you're gonna be
solve for
sorry.
y, you can either find a common denominator, or what would be easier is to just eliminate the denominators completely.
Right.
The reason that would be easier is because we only have one denominator. So it's really easy to just take this whole equation and multiply by y.
Oh,
That will eliminate the denominator.
I like to not do that correctly. I don't know.
I did that and then I thought I was wrong, so I.
No, that's good. So we have y times y is y squared.
Minus
Y times negative 1 is negative y. And then y times 6 over y
6y.
is like y over 1. And the y's cancel. And you get 6.
I
We
hate
get
that. What did you
CAs.
just do?
We get Leo.
What?
No, that's 6 in Chinese.
Oh, really?
I
thought it was loud.
hate whatever you just did. I really hated it. I just liked that.
You get 6y over y, which is 6. This is quadratic, which means everything needs to be set equal to 0 in order for us to solve it. So you get it set equal to 0, and then you have options.
So then it would
The
just be
square,
Quadratic
negative
quadratic
3
formula,
and positive 2.
factor.
Quadratic.
Factoring would be probably our fastest method.
And we can
If
get
it
two
works.
answers?
Yeah, it does.
So-
Oh, no, it doesn't.
Negative 3 and positive 2 multiply to
Oh,
negative
yeah.
6 and add to negative 1. So that's good. Which means
And two answers.
our answers are 3 and negative 2. Those are our solutions for y.
Do you have any restrictions?
Plug it in.
You do in theory have restrictions, but it would just be 0 for y.
So then x would be 4
wouldn't have
and
restrictions for
1,
x at
negative
all?
1.
Because there's no x's in the denominator, so there's a y in the denominator, so we would have one restriction for y, that y can't be 0, but we don't have any restrictions for x. But these are not restrictions, so when you find your two y's, you're going to take them, substitute them back into an equation of your choice and get your x.
X equals 4 and negative 1.
So the easiest one you would plug it back into is the second one.
That I got.
So if you plug 3 here, you get x equals 4, which means when y is 3, x is 4, you would have the solution 4 comma 3. If you plug negative 2 back in, you get negative 1, right? So when y is negative 2, x is negative 1, that means you have the solution negative 1 comma negative 2. Whenever you are solving a system of equations and you get two solutions for a variable, you either have to put your answer as an ordered pair or somehow distinguish which x matches up with which y.
Wait, so you want
If you just put y equals 3, y equals negative 2, and then you put x equals 4, x equals negative 1, that is incorrect. You're just saying random numbers everywhere. Remember that when you're solving a system of equations, you are finding intersection points, and you're finding sets of one x with one y that will satisfy the equation. So if you just say that y is 3, that's an incomplete answer. Y is 3 when? Okay, you have to say the y value with the x value. So the easiest way to do that is with the ordered pair. Now what this represents graphically, if we were to take this equation and graph it, which would be awkward because it's like not in a form that we would want to graph.
I just like zoned out and I just don't.
If we were to take this equation and graph it,
graphic.
it's an inverse variation equation. If we were to take this equation and graph it, whoops,
Oh man.
more like this.
Like I'm not
They
doing
are
that.
intersecting in two places, at 4, 3, and at negative 1, negative 2. And that's what we just found. We found their intersection points.
How did you just grab them? Oh.
I just like rewrote this so that it was like y equals.
Oh, okay.
Question,
That's weird.
are we gonna have to grab this on the
How did
test?
it
And
get-
second question, do we get a calculator on the test?
Third question.
You will get a calculator on a portion of the test possibly, but I haven't really decided yet because I don't really think you need one, and I think it would just inhibit you and make people cheat more than it would help you.
I
It's
don't
really
think we learned anything.
not a,
No,
yeah, we didn't really like use the calculator at all.
Okay.
How do you cheat with a calculator?
No.
Well,
Oh wait, that's not chapstick.
because this is y equals and this is y equals, the easiest thing you can do is just take 1 over x and set it equal to 3 over 4 minus x squared. That's your easiest option. Then you're gonna cross multiply, again, your easiest option. 1 times 4 minus x squared is just 4 minus x squared. X times 3 is 3x. This is a quadratic equation, so you want it set equal to 0. Typically, in addition to that, we usually want x squared to be positive.
Yeah.
So I'm gonna put everything on the right side of the equation so that x squared is positive.
What do you do if it's not? I kind of
And you just divide everything by -1 or multiply everything by a -1, it'll make your x squared positive.
Right.
Or you would use the quadratic formula and then it doesn't matter. But typically when we factor, we want x squared to be positive. If
I
x
feel
squared's
bad.
negative, it's kind of
Like,
hard to
didn't pay
factor.
attention to algebra 1.
So this
I
is
didn't.
x plus 4,
I didn't.
x minus 1,
No, you did.
and then that means x is -4 and x is +1.
That's
Neither of
really
those is a
good.
restriction. So real quick, the x restrictions would be 0 for this one, 2 and -2. Basically your asymptotes. These are not restrictions, so that's good. You would then plug this back in. So if you plug it back in, you can plug it back into either of them. This one's easier. So if you plug in -4, you get -1/4 for y. So that means you have one point at -4, -1/4. And then if you plug in 1, you get 1. So somewhere over here, these guys are intersecting,
Hello, Eric.
No, he doesn't know.
which kind of makes sense because they're both going to drift off towards 0. So at some point they'll probably touch. These guys aren't touching because they're separated by the asymptote. And then these guys we're touching in the middle.
How did you get